Okay, present. Yeah, thank you for joining and welcome back. If you're back for a second or third time. So today we're focusing on module 5's concepts, and this will be our last module. So we made it here. And also, since usually based on our previous scheduling, we would be only discussing the lab from the past module, but after reviewing the pacing and everything from the past 2 sessions, we've decided to adjust the scheduling a bit. So we'll finish up or introduce module 5 contents and concepts today, and then so if we make this adjustment, then we can save some more time to have bigger wrap-up sessions. So in this way, if we follow through the course, we can have a nice review, and also for everyone else who might be interested for more of a crash course kind of thing. So I think that would be more beneficial for everyone. So yeah, so stay tuned for more details about those review / wrap-up sessions. But today we're focusing on module 5, so we'll dive deeper into deep learning specifically for sequences. Today's agenda will be focused on recurrent neural network. So this is the network model used for sequences. These are the topics that we'll be going over regarding this. So first, we'll start by looking at the motivation behind this. So why do we need to learn about sequences in the first place? Why do we want to have these models that learn about sequences? We'll go over the architecture, so how the different components, how the model is structured. And since it's different from basic neural networks, so it also has some different ways of training it. And LSTM and GRU are basically 2 common types of RNNs that we're gonna look at today. And finally, we'll finish off by talking about the real life application. So we've talked about all this. Why is it useful in real life, right? At the end, we just want to use these tools to solve real world problems. Okay. So first, why is there a need to learn about sequences? And that's because sequences are basically everywhere. A lot of the problems involve having sequential data. So I've put a few examples here. So this one, I meant for this to represent text. So obviously, text is everywhere. You're reading these, or whenever you're looking at books or different writing, you're looking at text. And text is sequential, right? The words depend on each other. So that's an example. And if we talk about text, there's also going to be audio, which is a different form. There are also video. Yeah. So since we talked about audio, there's video, and video is basically different frames. They come together to form a video. So the different frames are also in sequences. And finally, this one's a kind of a slightly different example. So the stock market, you have different times, and throughout the time you have different points, and they form a trend. So these are all sequences, and it would be very useful to have some sort of model that learns this, and we'll be able to work with this kind of sequential data, right? Yeah. Okay, and just to get more about the intuition behind the RNN logic. So I was going through a few of the online articles about this, and I found this pretty cool experiment about how sequential memory works. So the first experiment is so you can try this on your own as well. Try saying the alphabet forwards or backwards, and then which one's easier. So if I say it forwards, like A, B, C, D, F, G, pretty easy, I think. But if you want to say it backwards, it would be like Z, Y, X. So it's, I think when you go backwards, you have to sort of think about it a bit more, and that's because you're trained on the sequence going forwards and not backwards. So for if you're suddenly trying to say it backwards, then it's harder, right? And something a bit different, the second experiment here. So if you change it up a bit and then start saying the alphabet from G, then it's, so if you try it, at least for me, when I tried this for the first time, I actually had to go back to A and then sort of get to G, and then it gets easier as I go on. So these are all because of the way our brain is trained on these sequences. And for RNNs, it's kind of in a similar sense. So which is what we'll be looking into today. Yeah, so we talk about like the motivation and the intuition. Let's take a look at more of the mechanics, like what its architecture is like. Yeah, so since it's for sequences, it has more of a unique architecture. So it's called a recurrent neural network, and recurrent actually means repeating. So you're basically, what's different about this is that you would be using previous output as input. So in this diagram here, you have input on this side, output on this side, and as part of the inputs, you also have the output maybe from a previous time step. So that's how it works. So because of how this works right here, you're able to process inputs of arbitrary length. And that's very useful for sequences because usually you have a sequence, it usually has arbitrary length. You don't know how long it is. So so that's the benefit of it. And another unique part of it is that the weight that you're using is shared across time. So it's shared across different time steps. And that's also beneficial since if you don't know how the length of the time, you might have too many weight parameters to do computations on. So when the weight is shared, it also makes it easier. Yeah, so that's what makes it unique. And if I can click on this, probably not. Let me just. This is the cool article that I found that has nice animations. Yeah. Just to get a more of a visual sense. So yeah, so these are like frames in a sequence, and from that sequence you can get a sense of where the ball is moving. So that's the intuition behind it. And it also shows, so we talked about audio as an example of a sequence. We can have different chunks of audio in a sequence. This is the experiment that we did. And yeah, so basically you're basically taking the output from previous times into consideration as you calculate the input from the present time. It has this pretty nice example here. So let's say you have a chat bot, and then you want the bot to classify what the user's intention is based on what it's saying. So then how do you use RNNs for this? Yeah, and it has this pretty nice animation here. So let's say the user is typing in, what time is it? Then you first break up the sentence into a sequence of words. You have what, you have time, you have it's, and the question mark. So then how does it work with the RNN, right? So you feed the sequences one by one into the network. So you start off with what, you feed it in, and it can produce an output. So that's the first time step. And then after that, it's a sequence. So you feed the next word in the sequence, you feed in the time. And of course, when you feed in this time, it also considers the states from the previous time step. So you can see as shown in the color code here. And you go on and on with this and this. And then you get the final output, and then you can use that final output and pass it maybe to another network for classification, to classify what the intent might be. So that's basically an example of how an RNN can be used. I think this is a pretty cool example since it also has the animations in it as well. Yeah, and yeah, so that's the architecture for it. And as we can see, it's a pretty different architecture, I'd say, from that we're used to seeing from the previous more basic neural networks that we've seen. So the backpropagation is going to be different as well. And just a quick recap, if we remember backpropagation for basic neural networks, it's for, so when you get the error by comparing what you predicted and the ground truth, you have to propagate or pass that error through the different layers and then adjust the weight accordingly. So that was when we had different layers. So for example, in artificial neural networks, maybe, but this time it's a bit different because we're on the time scale now. So how it works, it's still kind of similar, but you are, okay, in this diagram, we have the RNN on the left here. And how you can visualize it is you can sort of unroll the RNN through time. And that's what you have on the right-hand side. So yeah, then you can, instead of propagating the error through the layers, you're propagating the error from the last to the first time step, and then you calculate the error and adjust the weight. So yeah, as you can see here, it's you have the input at the first time, and then you also have the input at the second time, and this time you're considering the states from previous time steps. So then this way, as you go down, you're sort of taking into account all the parts in the sequence. Yeah. Okay, and for backpropagation, there's always been, for all neural networks, it has this vanishing gradient problem. And this is because gradient, when you're calculating the gradients in backpropagation, that calculation is dependent on previous layers. And similarly in here as well, it's dependent. So as you can see in this GIF here, as you go down, the gradient starts to shrink as well. And there wouldn't be as much weight adjustment, which could be an issue. So because of this vanishing gradient problem, as a result, you only have short-term memory. So going back to the article here, this also has a pretty nice visual. So you can see as you go down, based on the color coding, you sort of, I guess you can say sort of forgets the earlier states. So the later states become more dominant, and that's because of the vanishing gradient problem. Yeah, as you can see here, right? So then how we resolve that is by using LSTM and GRU, which we mentioned in the agenda slide. This stands for short-term memory and gated recurrent unit. And if I remember correctly, LSTM is just a generalization of GRU. So basically, they just have gates that selectively update the long-term memory. So that way, when you're doing the calculations, you have a blend of the short and the long-term memory, so then you don't forget the earlier parts. For this, I also found a similar article from the same author that's also pretty nicely done. Yeah, you can see it has these gates shown here. I can scroll down. Yeah, so in a general recurrent neural network, you're feeding, you're processing the sequence one by one, essentially. That's what they're saying here. And then you also have the state from previous steps. So that would be for a normal RNN. For LSTM, you have these gates now. Yeah, and I think the major part is the forget gate. So for this one, this is where you, what we mentioned here, it's selectively updates the long-term memory. So it chooses what to forget and what to remember. So that's what's different here. And for GRU, it's kind of similar as well. Yeah, so it's sort of different in how it uses the gates, but essentially, if we just want to get a higher level understanding of it, so it just, these gates can control the long-term memory. So you can, so now you would have some parts as long-term and some parts as short-term. So you wouldn't forget the parts from earlier on in time steps. Okay, so yeah, we've looked at this much. So how is it useful, right? So after you learn a sequence, it can do some sequence generation. And how that's useful in real life is you can generate music. So machines, I've seen some like news about like how machines can compose, how AI can compose music nowadays. And there's also image captioning, which I've shown in this diagram here as well. So you have this image, and then you use the CNN, which we talked about in the module 3, I believe, you can extract the important features in this image, and then you have the LSTM here, and then it's able to, based on what it's learned, it can sort of output a caption for this image, which is pretty cool. And you can also do classification, so sentiment analysis. I think we talked about that a bit in the last module as well. You can translate to, these are all pretty big these days, like machine translation, speech to text, converting these different sequences. And I'll plug do I have our, yes, it's here. Yeah, in UTMIST study groups, we have, on this page, we have the resources listed here. So feel free to check these out as well. I've put some links that I found, which are pretty cool about how you can try out these applications on your own as well. So TensorFlow has this. So you basically take the music, and it even visualizes the data for you. And then you can train it. And then it's able to generate notes, which is pretty impressive. So, yeah. It's amazing what it's able to do. Yeah. Okay. Yeah, I think that's like the overview of RNNs and how it can be used in real life. Yeah, thank you. Yeah, thank you for listening. And we can, if we have any questions or anything you want to discuss, we can talk now. Yeah. Let me stop.